Okay, morning everyone. Welcome back after the break. Now we are left with one unit, 3 modules, then that's it. Okay, so the modules which we are left with, or the unit is class design, and we're going to start looking at designing our classes. What do we mean by the class design? Well, we know that how does a class look? We can depict it. What goes in a class? Attributes and operations. But we're now getting to the actual design of that to link it to our programming. Okay. So you will see the first one is talking about class design, then defining the class internals, and then defining dependencies. So that word dependencies is probably a bit misleading for now, but really in essence we're talking about the associations, the relationships, the way in which these classes is connected. Okay, so initially for class design, you'll see the module is there. The objectives of this is to define quickly the purpose of class design, and then we're going to look at identifying additional classes and relationships needed to support this implementation of our chosen architectural mechanisms, and then to identify and analyze the state and transitions and objects of state control classes. We'll look at that also in the next module. So also to define relationship operations and attributes. So you'll see the purpose of this, what they are saying to us here, it's saying to ensure that the class provide the behavior the use case realizations require. Okay? So in essence it means that we need to look at our class and to see that we look at our sequence diagrams, that this operation that I have here can in essence perform what is required of it. Okay? Then to ensure that sufficient information is provided to unambiguously implement the class. So that when we have our class, that there's enough information in terms of those operations and attributes that when you have this, you can actually go and write the code for it. Okay, then to handle any non-functional requirements related to class and to incorporate the design mechanisms used by the class. Okay. So then there's also quickly a mention about when is this done during the lifetime. It's done as part of defining the components, as part of analysis and design. Now, there might be some inputs to this. The inputs in this case is to have you identify design elements, and ultimately the design classes will be the major output. Okay, so the steps which we will be looking through is the following: to create your initial design classes, then to define the internal class structure, dependencies, association, generalizations, and then so on. Okay. Now, what you will see in the class design considerations is things that we need to consider from previous work. Okay, so the considerations that we need to look at is how do we handle boundary classes? How do I handle my entities and also the control classes based on the architecture which we have? So a lot of this builds on top of the previous work which we have done, and then also to incorporate your applicable design patterns. Okay. Then to look at the architectural mechanisms which may be persistence, the distribution, which is related to your architectural mechanisms. Okay. Now, then they quickly go into a discussion about it. When we're modeling this, we might need to make a decision. Do I need to have many small classes? Or do I need to have a few classes, but they are going to have thousands of lines of code? So ultimately the class becomes big but I only have a few of them. What is problems with that? So if you have a few classes, yes, the coding is going to be very complex. Try to find a problem in that. It can take a lot of time. They are also saying to us it is less likely to be reusable, and it's going to be difficult to implement ultimately. Okay. If we have more or many simple classes, what does it say to us? Each class will really encapsulate or just cover a smaller portion of your total system. So that's why we are going to have more classes. And it's ultimately more reusable because that class only covers what is needed of it. Okay. Then it makes it easier to implement because you now have a smaller section to write from it. Okay. Ultimately at the bottom they give us a very good hint there. A class should have a single well-focused purpose, and a class should do one thing and do it well. Welcome. So that almost brings us back to the definition of a class which we had at some point at saying, but that class should have a crisp, clear boundary. If you start to put too many things in this class is going to go and become very big, and it's not going to be easy to implement. And you now to change it and to make changes to it becomes difficult. Okay. So what we've also mentioned that we need to make some decisions regarding our boundary classes. Now, this may be, for example, that you need to look at the user interface boundary classes, or how are you going to handle external system interfaces. Okay, we have spoken about this, and we have already mentioned how and what type of classes we can handle for our chosen architecture. But this might be some consideration that you need to make. Okay. So then there's also decisions which we need to make for designing our control classes. Are they really needed? Do I need them? Should they possibly be split? Okay. And then there's questions which we might need to consider on how do I decide basically if they are needed or if they might be needed to be split. So what we have here is if the class is, or the action is very complex, then we will have a control class. If there's a probability of change, what does that mean? It means that this class can change quite often. Okay? Then we might need it, and we could possibly even split it later on and to keep portions in one of the classes which is not going to be changing so often into one of the classes, and then to split the new work and to create some hierarchical structure for it. Then to look at the distribution and performance and transaction management. If it is needed, you might need to consider those things also. Okay. Yes.
So now, how do you identify, analyzing, how can you identify this type of thing can cause disturbance on how you're going to distribute the performance, the bottom line?
Okay, for example, distribution and performance, how does it have an effect on your system? When your system is scaled to one extent, and you might need to expand the system, you might need to incorporate the distribution into this. Let's say, for example, if we look at a banking system, the whole section is running, let's say the business rules is used by multiple portions. Is the rules different for when you're doing mobile banking compared to ATM banking? Think about it. Can you transfer money from one account on your phone, and can you transfer money at an ATM? Is it applying the same rules? Why do you say no?
Because the requirements on the ATM for you to transfer money are different from the requirements when you transfer money from your phone.
How are they different?
If you transfer money from your phone, you just have to, as long as you've just logged into your app. Most of the time you can have a shortcut whereby you just click there and then it sends, like on Standard Bank. So normally when I pay my rent, I no longer have to
But paying your rent, is that internal transfers?
It's external.
Okay, so that's a payment. Okay? If you are transferring money from one account to another account, let's say, who has multiple accounts at one bank? Okay? Have you ever transferred money from between the two accounts?
Yes.
Okay? Have you done it on the mobile application?
Yes.
Have you done it at an ATM?
No.
Okay, at an ATM, the rules really works the same as what you would see for your mobile phone. The interface and the layout of that will be different, but the distribution, where does it come now? Where does the distribution performance come in? If you require high performance of your system, are you going to keep one class? Are you going to have, if we go back to this discussion about many complex classes, many simple classes and a few complex classes. If you start looking at the performance of your system and really require high performance, are you going to have a few classes which must do all the work? Yes, because now you can distribute and just call on the class which is required at that point. Otherwise, you are going to be requiring a high amount of memory, because now you must have more objects open, or possibly fewer objects, but so big that it's handling too much work for you. Okay. And where does the transaction management come in? Transaction management. What must happen if you don't have enough money in your account for the transfer to happen? What must happen if you go to a shop and you pay with your card and you receive 2 SMSs that they've deducted the money? They've deducted it twice. Have any one of you gone to a restaurant and then you pay for your meal? You put in your card, you put in your PIN, you pay for it, and then you get 2 SMSs now saying that this amount has been deducted twice. It has happened a few times with me, and it happens. What should happen? What is transaction management? Either that whole thing must happen as a unit, or if some failure occurs, it must be reverted. What must happen with one of those deductions? It must be reverted. Okay, so a bit later on you might get an SMS which shows the correction. Okay, so transaction management has to do with that. Okay. Then there might need to be a few considerations for designing entity classes. we might need to look at objects that are often passive and persistent, and we might also need to look at the requirements and possibly to refactor our classes. Okay, what is refactoring? If you plug in some of your programming IDEs, Visual Studio, Eclipse, NetBeans, all of them have an option when you select some code to refactor the code. What does it mean? You might have an initial class, but now you can possibly break it up into portions. Okay, so we might need to do that based on the performance of our system. So if we have one big class and all of that, we might need to break it down into small little sections, which is just relevant enough. Okay. So that it can be split into the correct portions. You'll see there is actual lines there in the presentation if you look at it nicely, which shows to us that we still have our initial fat class, but they've now split it into multiple portions, multiple children. Okay. So then they go on to say to us, how do we need to look at our applicable design patterns? What is a pattern? It's a series of requirements with a... Who uses patterns? Are they used? Okay. Look at these desks in front of you where you're sitting. Were they just made? Would you say that each of them is the same? Where are they different? Biggest exception on that side, we have 5 seats, and on this side we have 4 seats. Okay? You see. But is this the width the same? There's a piece of glass. There's a section for cables that can come through. There's a portion for a case there. What? Okay, so where is this going? A pattern is saying to us ultimately, the best definition which I like is according to Grady Butch, a pattern provides a common solution to a common problem. What was the common problem here? We need to have some seating space, okay, which can later on be used to house a computer where you can work on it. Okay. So what was the common solution? Did they reuse that same solution over and over? Yes. They probably made one row and looked at it like, oh, that was nice. They made the next row. Okay. Another example. Our clothes. Does it just happen? How does clothes happen? My sister's a fashion designer. I'm not even creative. I think I had to learn creativity this semester writing on this board. Okay, if you look at a pattern, is there a common problem? The dress you are wearing, is it just for one size of person? Your shirt, is it just for one size? Is it one size fits all or what? Okay, so sometimes we may get that this range from size 8 to 40. I don't know. But the common thing is that we would like to make a shirt that looks like this, but the size might need to be scaled. So we might have this. And then they can start to make it smaller for the smaller people. Okay, that should actually come out. Okay. But it should still have the same idea. It should still have sleeves and body and so on. Okay. That's where we get into a problem. Two patterns. Now, how does patterns apply to this? We might get to a place of saying, and even in software engineering, when you're starting to develop a program, you might go and apply different patterns. We'll briefly discuss some of them here. This is patterns for web systems, which is based on the Java Enterprise Edition Core 2 JEE patterns. And then there is some which is listed here. Okay, so you'll see this is some presentation tier pattern. So what does that mean? It's patterns which is going to help us with the user interface. So some which we might use, for example, is a front controller. And then they tell us a front controller provides a centralized controller for managing the handling of requests. Okay, so every time that you open a web page, what are you doing? You're clicking on something. You're requesting new information. Okay, so that front controller can play the role of the guy who is handling your requests. Now, it might need to decide, okay, what am I going to do based on this? Am I going to send you somewhere else? Am I going to send you some other information? Okay, so you can do that for you. The view helper encapsulates logic that is not related to the presentation formatting into helper components. Okay, what does that mean? Where do we see these guys? Where do we see like a view helper? Cool. View page source. So, I just went to Google and I looked at the source. Is there something like this there? Remember we saying that it provides, or it encapsulates logic that is not related to the presentation formatting into helper components. So, these components may be even in other classes. We can move them out. Okay, so it's not related to your presentation, but it may be in actions. Okay, so if you are busy on Google site, on there, okay, what should happen if I type in here something and I selected enter? What must it do? Yes. Okay, so it's looking at it. What is it going to do if I don't type anything in there? Is it doing some validation? Okay, so a place where this is going to is to provide those actions for us, and that class or the classes which might be discovered from that can help us with those interactions. Okay. Then there's a few other ones, interception filter or dispatcher view. Interception filter facilitates the pre-processing and post-processing of requests. So it means that when you are accessing a resource or a site on the internet, it can look based on where are you from. Can you access this? Okay, so for example, a lot of people would like to stream Netflix from the US. Can you stream Netflix from the US in South Africa? Legally? No. Why? Because the content providers there placed restrictions on what content can we see in South Africa. So they might look and use pre-processing, they might look at your location information. As part of the request, there's location information, and then they say, but you can't access this. Okay, so there might be an interception filter which can be used for that. Then there's also a few business tier patterns. For example, the session facade, it hides business objects complexity. It centralizes your workflow handling. Now we spoke about the session a bit and the business logic and all of that. Now this guy can help us with a lot of that. What does it mean to hide complexity? If we say to you, go and study for a test, the initial task is to go and study for the test. But what are you really doing to study for the test? So, if we had to depict it in a sequence diagram, the initial task might be to study, go and study for the test. But what do you need to do to study? There might be a few things which is happening there. So for us, from outside, it looks very easy. That's why lectures are just delegating, go and study. But on the inside, what you are going through might be complex. There might be a few things which you need to handle in order to do this. Okay. Yes.
Basically, hiding complexity is just giving you a brief picture of what is happening.
From the outside, for me, it looks simple. Even this, from the outside, for me, it's simple. Go and study. But the inside, the actual object, the thing, what you need to go through in order to do that might be complex. Okay. If we look at an exam, for us it's easy to say to you, go and study for this exam. Nice. But what do you really need to do to study for an exam? You need to create some time. Get yourself motivated. Look at the material to be studied. What else? You see, I'm making it simple again.
Yeah.
Huh? Okay, so from your side, in actual doing it, there might be a few things which makes this very complex, which is we're hiding away from the outside. Okay, there's a few others which we can also look at. Then there's a bit more of a discussion about the front controller and the view helper. And then there's also, the business delegate. You will see this guy reduces the coupling between our tiers, and it provides an entry point for accessing the services that are provided by another tier. What is a tier? It's not like crying. Okay. In our applications, we may get to the place that we structure this, and this can be your presentation, business logic, and that can be your data services. So by structuring your application into different portions, you might need to get your presentation to access some business logic rules. Okay. So this is also where this is coming, and it reduces the coupling between it. Okay, how do we reduce the coupling? If I need to transfer money between accounts, do we need to do everything, all the small things? When I am doing it from my mobile phone and when I'm doing it from the web, do you need to check if there is money?
Yes.
Okay. Does the presentation need to check if there's money? Ultimately, the biggest thing, and it comes to this also, what do we want to do? We've selected the amount. You entered the amount. You've selected the from account, the to account. What do you now want to do once you've selected transfer? What must happen? It must transfer the money. Okay, so, okay. So in essence, we would like to have one call to the business logic to transfer the money. We don't want to have small calls going there. And this call would almost like be like this guy. Go and study. Transfer the money. But to transfer the money, what does it need to do? It need to check. Oh, is this amount available from the from account? And then if it is available, what do we need to do? Is we need to deduct it, and then we need to credit it. But from the outside, from the presentation, it would still look like one operation, one call. But there might be a lot of small things happening here before we can do this. Okay. So that is just a business delegate where it reduces the coupling. Then there's also mention about the session facade, which provides course grain services to the clients by hiding that complexity to your business object. Okay. Then there was a few review questions. Okay. Okay, so there's also a few interesting questions, these last two. Would one always have a session mean in a sequence diagram? What do we capture inside the session? What is that guy going to do? This. So we're looking in that portion. Do you also always need to have some session there? So, a class which can handle the business logic? Was there business logic to do this? Not really. Okay. Where does business logic start? Possibly. For us. When we go and sign in, when I start to access my account, there may be business logic and business rules related to how can I sign in. Okay, what can I do then? But this is not really, no. Okay, and what would happen if there's no controller? No.
What time is it?
Get a watch.
Or you're trying to say what? A fucking watch?
I'm saying get a watch to look at the time. Okay. What would happen if there's no controller or session in your sequence diagram? When you created an application in VB, and you had your buttons and text boxes there and radio button, and then you had a button here. Wouldn't you actually write the code for the event that must listen to the click of the button? It's not a trick question. To some sense, it may think like it. Okay. So, in VB or at C#, when you're creating these forms, what do you see? You might go and create your user interface. But where is your coding for this? Most of the time, people just leave it on that class. It can be separated out into another class. One portion of the class will handle the user interface. Another portion will handle the event listener, that action that must listen to this. But it can also be split out. But what would happen if there's no controller or no session? Then your presentation, the class that handles your presentation, this guy, must now do all the interactions with your database possibly. Okay, so I might still need to fetch some data. My presentation might need to now directly access the database. Okay. What are some problems with that? You're now starting to write data access code in your presentation classes. Okay. Problems with this is that if you need to make changes to how you're accessing your database, all of this information can become problematic. Okay. Any questions, guys? Yes.
So, sir, when you identify your patterns, you identify on the analysis or when you are designing?
Okay, so when you're looking at patterns, you must also take into consideration that the implementation environment you're going to work with. The patterns we spoke about, these patterns comes from a book, the core J2EE patterns. You can also go and look, there's a website where they're hosting these patterns, where they're discussing it in a lot more detail. Now, the patterns can be applied across languages, but the implementation sometimes is not always possible in all languages. Okay. But if we are going to design, for example, an embedded system, the patterns which we can apply might be different compared to the web. Okay. Or the implementation of those patterns may be different due to the language constraints which you are having. For an embedded system, what language are you using? You probably C or C++. This is web. So you're sitting with some HTML and Python or PHP to handle all of that for you. Okay. Any other questions, guys? Okay. You must enjoy your week.